So next topic, cluster. Okay. So we'll group the ESXi host logically in the vCenter. So physically there will be no change in their connectivity. Only in the vCenter we will group them together. So hard disk is if there is any problem in the hard disk here. So which hard disk? If virtual machine is here, the virtual machine is here, and hard disk the virtual machine will be stored in one of the data store here. So problem on which hard disk you mean? Virtual machine hard disk or the hard disks which are presented in the SAN array or ESXi local hard disk problem? Okay. So as per your question, I can understand it's a problem on the ESXi local hard disk. So to replace any hard disk here, we will vMotion VMs from one host to another host, and it doesn't need to be same VMs to come back. Any VM can come back. VMs will come for sure, but not the same VMs which were vMotion from here to here. In the next feature inside the cluster, there is a feature called DRS. It will take care of the vMotion, automatic vMotion. So the same VMs when you need to come, any VM can come. Normally, an ESXi machine will be connected to the network and storage in this manner. Okay. So two to the storage connections, two to the network connections. Everywhere there will be redundancy towards the storage, towards the network. Okay. So now virtual machines are here. Be stored in the common data store. These many data stores are there. Now we will group them logically. Physically, they will be in the same location as they are in the same rack in the data center. There will be no change in the data center position of these servers. Okay. Only in the vCenter, we will group them like this. Okay. We can call it as cluster. Only in the vCenter, we will group them and call it as cluster. Logically, we are grouping them. Okay. Physically, there is no change in the data center. In our lab also, the servers will be in the same location. However, we have placed them. Only in the vCenter, we will group them. Create a cluster, add these ESXi hosts into that group called cluster. Purpose of this grouping, there are two major advantages, HA and DRS. We'll see each feature separately. And minimum requirements. Shared storage. Minimum 2 hosts in the cluster. Maximum 64 hosts from 6.0 and later. Minimum requirements for clustering. Minimum 2 hosts are needed. Okay. And maximum we can place 64 hosts in a single cluster. If it is older version 5.5, it was 32 only. Maximum it was 32, now it is 64 hosts. We can place together in one single cluster. And it should be shared storage. Whatever the data stores connected to ESX1, let's say L1 and L2 data stores are connected. And the same data store should be connected here as well. L1 and L2 data stores should be connected. If it is like this, it's not called shared storage. It is not recommended. Should be exactly like this. L1 and L2 data store should be visible to both the hosts. Fine. So, and same CPU family hardware. At least the CPU family should be same when you are ordering the hardware. Should be same CPU hardware. Otherwise, vMotion will not happen. Okay. And all the technical tasks are restricted within this cluster, like vMotion, SVMotion are restricted within this cluster. Okay. So we cannot, if there is another cluster, normally we don't do vMotion across the clusters. Okay, within the cluster only we will do. So if there is another cluster, okay, for this host, let's say L3 and L4 data stores are connected. The L1 and L2 data stores should not be visible to the second cluster. L3 and L4 data stores should not be visible to the cluster 1. It should have their own data source set of data stores. It should have their own set of data stores. These data stores should not be visible here. These data stores should not be visible here. Okay. That's why while sharing the WWN address, we have to share accordingly. If you are attaching a LAN here, share only these WWNs. They will map it to these hosts only. If you share this WWN, it will be within this cluster. It's all about how you inform to the storage team. You have to share only hosts from the same cluster. Fine. So creating a cluster. The data center, right click on it, cluster, name it, just give an OK. Don't enable any other feature, just right click on the cluster, right click on the data center, select new cluster, enter a name for it. Okay. So, and if you want to add the host, that we are already aware of it, add an ESXi into the cluster. Right click on the cluster, add host, enter ESXi IP or name, next. We have already added ESXi host into the vCenter, right? Same step will normally on the cluster will do. If the host is already in the already in the vCenter, just drag and drop. It will work. Okay. So we'll add into the cluster. So Bangalore is the data center, right? So right click on it, new cluster, enter a name. This name of the clustering normally depends on the purpose of the applications which we use here. If it is production cluster, they will say production cluster. If it is development, they'll name it as dev. If it is testing, test. Specific application, something like telephone application, so tele, whatever it is, many. Depends on the application purpose they use. So in our case, we'll just name it as lab, and we do not enable any other features as of now. We will enable later. Okay. Click on OK. You can see the cluster named called lab is created. The icon itself looks like multiple ESX hosts merged together. Okay, you can see three ESXi hosts merged together. Icon is represented in this way. You can see if you expand the cluster, you can see if there are hosts are already part of it. Right. So if you want to add host, right click, add host. Here you have to enter the host IP, username, and password. If it is already within the vCenter, you can drag and drop also. Select the host, drag. If it is applicable to release, release here. Now see, this host is added into on this cluster. Fine. So we can add if it is already in the cluster, drag and drop. If it is already in the vCenter, drag and drop will work. If it is not there, right click on the cluster, add host. Fine. And minimum 2 hosts, maximum 64. Remember this maximum number, it's a common interview question. How many number of hosts we can place in a cluster? Okay, maximum 64 from 6.0 onwards. Clear? And the data stores which are connected to cluster 1 should not be visible to cluster 2. The data stores which are visible in cluster 2 should not be visible to the cluster 1. Fine? Next. If a host is like this, connected to the same storage and same network, I'll just connect one cable or maybe two, I'll connect like this. And this host is not part of any cluster. Let's say ESXi 5. It's not part of the any cluster, cluster 1 and cluster 2. It's not part of any cluster. Connected to the same data, same storage. And here L1, L2, L3, L4 all should not be visible. Something new data store should be visible. Let's say L5 is connected here. Okay. This host is called standalone host. A host which is not part of any cluster, maybe within the VC or outside the VC. Maybe it is added to the vCenter or not added into the vCenter. If it is sitting idle like outside the cluster, it's called standalone host, which was even before we move into this cluster, right? It was outside the data center, outside the cluster, within the data center. It's not responding state. We cannot manage now. Let's just disconnect. Remove. So right click on the data center, add host, ESXi, root and its password. Okay. Now host. This host is called now standalone host. It is not part of any cluster, but it is added in the vCenter. Okay. This is called standalone host. Even if it is not part of vCenter also, it's called standalone host only, within the vCenter or outside the vCenter, but it is not part of cluster. Okay, that's called standalone host. If there is any problem here, until you fix the problem, the VMs will not come up. Clear? So if there is any problem on this host, until you fix the problem, the VMs will not come up. If you see cluster host, the VM is running here. If there is any problem here, this virtual machine immediately will power on the second host. It will come here immediately. Okay, by HA, here the HA feature. HA you can enable only on the cluster. If it is standalone host, cluster is not applicable. Okay, fine. If the VM is part of cluster, in case of host failure, VM will automatically restart. That we will discuss during HA. Fine. Any questions from this portion as of now? Clustering. Clear? Minimum 2 hosts we can place in a cluster, maximum 64. All the hosts in the same cluster should have same data stores connected to it. Okay. And these data stores should not be visible to any other cluster. Fine. And if a host is outside the cluster, it's called standalone host. If you want to add into a cluster, drag and drop. If it is already in the vCenter, if it is not in the vCenter, right click on it, add host. Fine. The benefits of clustering is HA. Main feature is HA. We will discuss about HA now. Any questions meanwhile? And I'll give you one scenario here. Just try to think and answer if possible. Okay. The virtual machine is located here. Let's say on ES6i5. That means it will be in the L5 data store. Now this host is failed for some reason and VM is down. If it is a part of cluster, at least HA will take care of VM migration to another host. But this VM is outside the cluster on a standalone host. It is an L5 data store. Now, if this host is failed, VM will shut down. We can't avoid that. Okay, it will be shut down. But it will take, let's say, 1 week. It will take 1 week to fix this problem, and customer is not okay to wait for that long. Technically, is it possible to help him to bring this VM quickly on any other host, either cluster or outside, at least on this diagram? Possible? Yes. How? Which one? Host is disconnected. SV motion is VM is inactive state. We cannot migrate. We will not. If you right click on it, there will be no option on a disconnected host. So if you see, if the host is disconnected, if like exactly the same situation. This VM is disconnected because all hosts are disconnected. This VM is also disconnected. Now I want to bring this VM to this host. Right click. You can't migrate for SV motion. And if you add this host now into the cluster, it will be still disconnected only. You cannot bring it back. What possibilities are there? Any guess? Just think logically. Just look at the diagram. There is no limit for clusters. You can create any number of clusters. And if you have, let's say, 50 hosts, it doesn't mean that all should be in the same cluster. Depends on production, how many hosts you need for production, put those many hosts. Another cluster for development, put those many hosts. Okay. So even the cluster supports maximum 64, Okay, if you have, let's say, 60 hosts, but for development, production, testing, all different purpose, you don't need to place them all together in one cluster. Production separate, development separate, testing separate. So depends on necessity, they will place the host. And now come to this situation. Any possibilities here from remote? No idea? Okay. Okay. So it's a virtual machine is stored on L5 data store, right? And this is not visible to any of the hosts. Ask the storage team to map this L5 data store to any of the cluster. So he will ask which cluster you want to present. So inform him cluster 2. Let's say share this WWN address, and he will say I have mapped the LUN 5 to the cluster 2. You rescan it here. It will automatically visible because it was already formatted with PMFS, right? So L5 data store will be created. Okay. Once it is visible, we can browse through this file folder, select VMX file, and you can bring this virtual machine here. Okay, quickly we can do that. Fine. This way we can bring this virtual machine up. If it is in local hard disk, instead of storing in the L5 data store, if it is in the local data store of the ESXi machine, we cannot bring. Host itself is down, right? We cannot present this file. We cannot access these files from outside. It's not possible. If it is in L5 data store, at least we can ask them to present it here and bring it. Fine. Here. Okay. So that logic we have not discussed, registering a VM from here to here. No, but that's fine. So we'll go to HA topic now. So normally, if it is a traditional machine, physical server with Windows operating system and some application, if there is any problem on the physical hardware, hard disk failed, processor failed, maybe motherboard itself crashed, whatever it may be. If the physical server is down, OS will shut down, application also will shut down. If the computer itself is dead and OS will not power on, even application will not start. Okay. Until you fix this problem, this will not come up. That was the situation in the traditional days. It may take 1 day, 1 week, sometimes even 1 month also. Until then, this application will be down. Customers used to face that impact. Okay. So if a physical server is down, OS will be down and application also will be down. Until you fix this problem, it will not come up. Okay. If it is ESXi machine, if same thing happens on a ESXi machine, physical server, and multiple VMs are running on top of it, all the VMs will be impacted. All the VMs here will be impacted. Compared to this situation, here there will be more impact because multiple VMs are down now. Okay. Many virtual machines with a lot of business applications are down. Here, at least it used to be one application. Here, some 20 to 30 applications are impacted. Until you fix this problem, this will not come up. Okay. To overcome this situation, they have developed this HA feature on the cluster level. Okay, we'll see now how it works. Name of the feature is HA. It's called high availability. Fine. Whenever an ESXi host fails in a cluster, all the VMs which are running on this cluster, sorry, on that failed host will be automatically restarted. They will power off here. We cannot avoid that because it's an unexpected failure. If you know that it is going to be fail, we will do vMotion from here to here. And we don't know when it will fail, right? Hardware or software, ESXi OS level or the hardware level. We cannot predict when it will fail, right? So in that situation, it is an unexpected failure. If it fails, we will not have enough time to vMotion. Immediately they will power off. Once they power off, HA will automatically power on these virtual machines on the another host. Understood? If you have enabled HA in the cluster, it will automatically restart on the VM. It will power off here and it will power on here. A business application will be down. We cannot avoid that because it is unexpected failure. Okay? Suddenly some hardware or software is failed here in this layer. Okay? So VM will power up, but quickly will recover here. Before you come to know that there is a problem, the virtual machine will be rebooted here. You can find the problem here later and fix it later. There will be no impact, at least. There is no harm in waiting, at least. Okay. So virtual machines are already running on the second host. You can fix this problem later. VMs are running on the second host. This process happens automatically. Automatically, HA will power off VMs here and power on here. Okay, we'll see that technically how it works. So very important for interview point of view. What is HA? How it works in the backend? What is the HA backend mechanism? Okay, definition you should know well. If a host fails, all the VMs will restart. Remember the word restart. So definitely there will be impact, but it will be minimal. Quickly the VM will be restarted here. Instead of waiting until you fix it, they will immediately will be recovered here. That's why compared to older days, your virtual machine and applications on the virtual machines available for more time. You don't need to fix this problem, but applications are already running. Okay, so that's why your applications or business will be available for more time compared to older days. That's why they named it as high availability. Because of vMotion and because of HA feature, customers are using vSphere a lot. Because these features helps customer infrastructure to run the applications all the time. Okay, fine. And if you want to achieve this benefit, we need to enable HA on the cluster. For that, minimum requirements, nothing but same cluster requirements. All cluster requirements should be satisfied. Minimum 2 hosts, same CPU family, same network settings, shared storage. Okay, all the cluster requirement should be satisfied. If you want to enable HA, go to cluster, configure tab, vSphere availability, edit, enable it, click on OK. That's it. HA will be enabled. This is one-time task on the cluster. Even will not get chance to enable it. So whoever is building new cluster, new host, they will enable it. That's it. One time, just one tick mark. Okay. So select the cluster here. Go to configure tab, vSphere availability, edit, tab. That's it. HA is enabled. So whenever a new cluster is created, it will be enabled like this. So that's why everybody will not even get chance to work with HA or cluster. But the problem is like interview point of view, very common interview question. Okay. Fine. So if you enable HA like that as a simple like one tick mark, we just on tab, we just enabled it, right? If a host fails here, automatically VMs will restart from failed host to the new host. Any host, it may fail, VMs will be automatically restarted on another host. Business applications will be running. You can find about this problem later and fix it later. Okay, fine. No. Now we'll see how it is happening in the backend. You enable HA, that's fine, and it is working as you expected. In case of a host failure, automatically the VMs are restarted also. As we discussed, it is working also. But very important interview question is what happens in the background? How HA is working when a host is failed? Who is that powering on the VMs from here to here? What is the overall background mechanism? Okay, let's see. Once you enable HA here on the cluster level, one small service will be enabled here. It's called HA agent. HA agent will be installed in this host and this host as well. Okay. So HA agent will be installed here and HA agent also will be installed here on this host. Once it is installed, it will go for master election. It's something like once a new class is formed, class people leader will be selected by the teacher, right? And he will be given with some additional responsibilities to take attendance for all the students every day, okay, to conduct some basic exams or maybe to distribute some exam papers, whatever it is. Along with other students, he will also be following the same rules. He should also get same attendance percentage, pass marks, whatever it is. But he'll be given with some additional responsibilities based on his extra qualities. Here also, once a new cluster is prepared, once you enable HA, master will be elected. There will be some election criteria. One host will become master, rest all the hosts will become slaves. Okay, master and slaves. Master will be initiating the heartbeat. So at 8:30, I am fine. How are you? And this slave will respond at 8:31. I am fine. How are you? 8:31. I am fine. So this message will be keep happening between the master and slave. That's called heartbeat message, verifying the health of the neighbor host, whether it is down or up. To understand whether it is really up or down, it will be happening. Okay. In case of a failure, let's say slave is dead. Slave will not respond back to the master. Second message also it will not respond. Third message also it will not respond. So then master will decide that host is dead. Let's restart the virtual machines which were failed on the slave. That's all overall briefly it will happen. We'll go in depth now. Okay. Once we enable HA on the cluster, an agent will be installed on every host called HA agent. HA agent will be installed on every host in the same cluster. Once the agent is installed, it will go for master election. Once the master is elected, it will be sending heartbeat message to the slaves. If slave is not responding within a particular time, the master will decide that slave is dead and it will restart the VMs from the failed host to the any other available host. Clear? So once we enable HA on the cluster, first step, HA agent will be installed on all ESXi hosts in the cluster. Okay. This HA agent is called FDM, Fault Domain Manager. Name of the HA agent is called FDM. Okay. FDM agent will be installed on every host in the cluster. Once it is installed, then it will go for master. master host, slave host. Master, one master per cluster, rest all the hosts are called slave host. Here, if there are two hosts, one master and one slave. If there are 10 hosts, one master and 9 slaves. If there are 64 hosts, one master, 63 slaves. Okay. One cluster will have one master and rest all will become slaves. If there is another cluster, okay, that cluster also will have one master and rest all will be slaves. Okay, like. And election criteria, how a master will be elected, very important. Master election will happen based on these two criteria. Okay, election process. Whichever host has more number of data stores connected in the cluster will be elected as master. So now let's say here L3 data store is also connected. L1, L2, L3 and 3 data stores are connected to ESXi1 and ESXi2 is connected with only 2 data stores, L1 and L2. Okay. Now ESX1 will become master because it has 3 data stores, right? L1, L2, L3, 3 data stores. Here it is L1 and L2 only. Here there are more number of data stores connected. So host with more number of data stores connected will be elected as master. So this host will become master now. And this host will be slave. Clear? In case of conflict, let's say if it is like this. If this host has 2 data stores, normally as per cluster requirement, we will connect only 2 data stores here as well. That's the cluster minimum requirement. If 2 data stores are here, same 2 data stores will be visible here as well. Clear? Now, host with lexically greater MOID will be elected as master. Okay. So MOID is called managed object ID. So in the vCenter, if you see, this is vCenter, right? We have created data center, cluster, some hosts, some VMs and all. So vCenter will assign one number to every object here. One number to VM, one number to host, one number to this host, and another number to this host like that. It will be assigning one number, unique number, 1, 2, 3, 4, 5, like decimal digits. Okay, it will be assigning one ID to one object to identify what object it is. Okay, to identify this is a host 1, this is host 2, like that. It will assign one number. That will be a unique number. So once it is given a number, let's say 55 to this host, it will not be given 55 to any host. Maybe this host is 57 or any other object will be 56 like that. It will not be same number anywhere in this within the vCenter. That's where VMware is choosing managed object ID. Using this ID, it will decide the master. And it's not based on our calculation, it's based on lexical calculation. We'll see the lexical calculation here just simply to understand. Something like this. From this number, if I ask you, like as per our calculation, what is the greater number? Which one is the greater number? From here. Greater number, our calculation. 239 is the greater number. Now, whichever host has 239 will become master. But it's not our calculation. It's something called lexically greater calculations. Lexical calculation. So lexical calculations are different than our calculations. They will split the numbers like this is 8, 7, 9, 2, 2 separately. 2 separate, 3 separate, 9 separate. 8, 9, 6, 9. They will split like this. Now check the first number first. Okay. So here 8, 7, 9, 2, again 2, 8, 6. Out of 69 will remove 9. Only 6 will consider. Out of 87, 7 will be ignored. 8 will be considered. Now look at these numbers. Which one is bigger number? 9.
9.
So host with 9 is the lexically greater number. Host with 9 will become master in this case. One host has 8, one host has 7, another host has 9. So like this. From these numbers, host with 9 will become master. Clear? So they will split the numbers one at 1 and based on the number they will change this number, they will identify that which host is master. Understood? And I'll remove 9 now and you tell me which one will be the next master. Now tell me which will be the master.
8.
So this should be master, but there is one more thing, one more object with 8. So this one and this one, right? Two numbers are match. That means conflict. Here 8 and here also 8. And then it will go for second number. Here there is no second number. Here there is 7 also. No, here, I mean, same number. This between these two numbers only now. There is a conflict between 8 and 87. Now first number is 8. Here also first number is 8. It is same. Okay. Now second number, there is no second number. Here there is second number called 7. Now this will become master. Clear? And now I'll remove this one. Now 8. I'll remove this one now.
7.
7 or 69.
69.
Here it is 7, 2, 2 and 6. Which one is greater number? 7. So 7 will become master. Now 69. Now
239.
yes, 230. That's it. And you don't need to worry about this calculation, just for your understanding. I gave you that example. You don't need to worry about these calculations. Nobody will go that much. If you know these two points is more than enough. Host with more number of data stores connected will be master in case of conflict. Host with lexically greater MOID will be elected as master. Then they will ask what is MOID. It's a managed object ID. What is it? Unique ID identifier. Okay, assigned by vCenter to its object. Identify what object it is. So it will assign one number, something like the teacher, class teacher will assign registration number to each student, right? 1, 2, 3, 4, 5, just to identify which number belongs to which person. Here also the same. vCenter will assign one ID to the object to identify which object it is. VM1, VM2, VM10, A61, whatever it is. So to remember these objects here in the inventory, vCenter will assign ID to all its objects. This is called inventory objects. Fine. Next, master is elected, rest all the hosts will become slaves. And technically, there is no reason that I want this host only to be a master. For a teacher, any person with a good quality, what may be based on first exam result, whoever may be, that person will be elected as class people leader. Here also like us. For administrators, we don't need to worry about which host to be a master. We don't need to do any favor for them. It will be any host, right? And that person also will be getting the same like class people leader. Even though he is selected as leader from the class, he should get the pass mark, right? Same like others. He should be having same attendance percentage. He should be behaving like same other person. but will be given with additional responsibilities. Here also the same exactly. Master host, even though if this is master, here also VMs will be running, here also VMs will be running. No extra treatment for the master. Same like others. But its additional responsibility is to find the heartbeat information. Next one is master will be sending heartbeat information via management network to the other host. Something as I said, right? A simple message at 8:50. I am fine at 8:50. How are you? Slave will respond back. I am fine at 8:51. How are you? This will be keep happening between the primary and secondary. Okay. And let's say there is a problem with network connectivity. There are two network switches. If there is a problem in one path, still it will use second path. But for some reason, both the network connections are down. Both switches are down for some reason. Okay, network switches are shut down. Normally, it's a rare situation. Both switches will never shut down. Any one only will be down. Failing both at a time is very, very rare. Okay, not even one out of maybe 100. Fine. For some reason, if it is down, both are down, then master will decide, right? Slave will not respond back to the master over management network. నెట్వర్క్ డౌన్ అయిపోయింది కదా స్లేవ్ రెస్పాండ్ అవ్వలేదు మాస్టర్ మెసేజ్ పంపించినా ఇక్కడికి రాదు ఇది మెసేజ్ పంపించినా ఇక్కడికి పోదు మాస్టర్ even can't send the heartbeat message to the slave also can't send to the master. Okay, then it should master should treat slave as a dead, right? But it will not do because slave is not dead. Only the problem is network connection now. Network is problem, but this slave is running fine. Clear? Slave is not dead, but due to network problem, master is not getting heartbeat. Then master should understand that slave is dead. It's something conflict, right? That's why master will depend on two heartbeats. One is this one, management network heartbeat via management port group, and another one is data store heartbeat. Even though they are sharing the heartbeat message over management network, they at the same time they will be writing the common heartbeat message in one of the data store. In one of the common data store, out of L1 and L2 are the shared data stores, right? So any one data store will be selected as data store heartbeat. That cluster will automatically select any one data store. Okay? Cluster automatically will select any one of the data store has any one of the data store for data store heartbeat. So here also in the vSphere folder will be created automatically. They will be writing their heartbeat information here as well. Even though they share here, they will write their heartbeat message here also. So two heartbeats. One is management network heartbeat, another one is data store heartbeat. Okay. So they will be exchanging the heartbeat over management network and also writing the heartbeat message in the data store as well. Now, in case of network failure, both switches are down. Master will think that something wrong with the slave. Let's check its heartbeat in the data store. Master will go and check here what happened to the slave, why it is not responding, whether it is writing heartbeat here or not. If it is writing here, that means slave is fine, right? If a slave is updating heartbeat message here, that means it's running fine only, right? Only there is problem with network. For some reason, let's say it's not writing in the storage also. That means these two connections are also dead. It's very, very rare, not even 1 out of 100. All 4 switches at a time they fail, right? It will never happen. For 2 network switches and 2 storage switches, stopping at a time is not even 1 out of 100. That's the reason. Then when it will not receive the heartbeat, in case if there is actual problem on the host, if there is a problem here itself, then it will not respond back, then it will not update here as well. Yeah, coming to that point, if master fails, what will happen? We'll come to that point. Okay. As of now, we are trying to find if a slave is dead, how a master will come to know that slave is dead. One is management network. If a actual host failure, it will not respond back in management network. It will not be writing in the data store heartbeat also. Then master will understand that it will wait for 3 iterations. That means 3 heartbeat messages. If it is not updating over management network, and also if it is not updating in the data store, then master will think that host is dead. Then how master will come to know which VMs? Let's say V1 was powered on, V2 is in power off. This is on, and this V2 is power off state. Then how master will come to know that before failure which were powered on and which were not powered on? Fine. So here,
Responding.
no, there is something called. Just HA state file in the common heartbeat data store, along with storing the heartbeat. Here there will be something called HA state file. HA state file. In the same folder where they are writing heartbeat information, there will be something called HA state file. In that file, every host will be updating the VM power status. So out of which V1 is powered on and V2 is powered off state. That update will be there in the state file. Now, if your class if this host fails, you tell me both should power on or any one should power on as per HA definition. V1 was
Both.
in
Anyone
power
can
off,
power on someone.
V2 was in power off state. Both should power on.
Yes.
Anyone can, sir.
Any one only. So which one? Like V1 or V2?
Mm,
If both power on, then what is the meaning? Like why we kept power off here if it is powering on? We kept it powered off for some reason. If it is powering on, there is no meaning in that, right? And read the definition here. All the running VMs only will be impacted. Powered off VMs, leave powered off only. We manually powered it off for some reason, right? Before host failure, it was in powered off state means we don't want to use that machine. If HA restart that VM, there is no sense in that, right? So that's why it will power on only the running VMs. It will try to read this HA, master will read the HA state file and it will understand which were running and which were not running. And based on that information, it will write it here. It will power on here. Clear? Any confusion? So based on host management network heartbeat and data store heartbeat, master will identify a host failure. Clear? So if a host is not responding over the management network and also over the data store heartbeat, master will identify that host is failed. So it will try to fix that. So and based on HA state file information, master will understand which VM was in powered off state and which VM was in powered off state. Any question? Yes, only powered on VM supposed to be ordered. If master goes down, there will be election again on the remaining host, and new master will take care. Okay, if your master fails, new master will be elected again quickly, and based on the new master response, it will power. And I'll give those interview questions tomorrow, like what if master goes down, HA state file information again. And also, let's say if this host fails, all the VMs should power on here. What if there is no RAM and CPU here to power on? Okay. As per HA definition, they should power on here, but there is no RAM and CPU here to power on. What will happen? So those things we will discuss tomorrow.